probability, this is stuff that you guys probably remember from before, you just might have forgotten. Probability of an event occurring is usually written out like this. Probability of event. I don't know what it is, it's just something. The way that you calculate probability is ways event can occur. Over total possible ways. For example, if I want to take a deck of cards and I want the probability of picking a jack. How many jacks are in a deck of cards? 4 of them. So the probability of getting a jack would be 4 out of how many total possibilities are there? 52. That's all it is. And you always simplify your fractions. Okay?
That's kind
All right, well, let's make this more specific then. What if I want to find the probability of a black jack? 2 out of 52. Okay? Your probabilities have a definite range. The probability of an event occurring is always less than or equal to something and greater or equal to something else. What are those somethings and something else's? 0 and 1. Can a probability ever be greater than 1? Can a probability ever be negative? Will the probability of you not having homework equal 0 today?
Yes.
Yes. Will the probability of you having homework equal 1? Yes. The probability of you having homework tonight from me, 1. It's going to happen.
0.
It's definite.
0.
99%.
Gun, I don't care if you do the homework or not. So you can say it all you want. Okay? The probability of you annoying me right now, 6.
But it can't be.
Oh yeah, you're right. I'm messing with you. Yeah, I'm not very smart, right? Not at all. I'm not SMRT. Okay?
Hey, that's oh my gosh.
Boy, gotcha, Mr. Murphy.
You misspelled that.
I know. So let's talk about the evil dice.
Oh, sure.
Let's talk about the evil dice. The 6-sided numbered cube, as most books will put it, but for some reason this book actually decided to call it a die, which is weird because most books don't, because I think they look at gambling and dice as evil and just bad things. So the probability of rolling a die, if you have a 6-sided die, how many possible outcomes are there?
6.
There's 6 of them. So the probability of rolling a 4 will be 1 out of 6. We agree?
Yeah.
Okay. The probability of rolling an odd number would be 3 out of 6, otherwise known as 1/2. All right. The probability of rolling less than a 7. 1. Right. So what we're doing here is we're looking at what's called the theoretical probability. A theoretical probability is what it should numerically work out to be. There's a difference between that and the real world. Real world outcomes use what's called an experimental probability. So in theory, if I roll the die 6 times, I should get all 6 numbers. In reality, or in actuality, that doesn't always occur. So let's take a look. 1. Make sure I get this. You got a 1.
You got all 6.
I think it's amazing how
5.
the die, pen, and shirt all match.
I'm fancy.
You played it a lot.
6. Ooh. 1, 5, 6.
We're halfway there.
6.
Also,
Ah.
doesn't count.
1. So 1, 5, 6, 6, 1.
Just to write that down.
1. So I rolled my experimental probability was 1, 5, 6, 6, 1, 1. So according to my rolling, what was the probability that I'm going to roll a 1?
Half.
Half time. See how experimental probability doesn't necessarily match up with the theoretical. Now, people actually use this experimental probability to help them with odds, with wagers, with gambling, with lottery numbers. If you go back and you can search into databases of the most frequently picked lotto numbers, people look at that as far as, well, 22 comes up that often, I'm going to try and pick 22. Even though theoretically, you still have the same probability of doing so. Okay? So there's always a little bit of a difference in how these things look at. Yes, sir?
Wouldn't, if you rolled it like 100 times, wouldn't that theoretical probability kind of start?
In a large sample size, yes, you are correct. And over the next, because what's going to happen over the next couple of days is that I won't have third hour because they'll be doing this testing stuff, but I'll have you and 12th hour. And you guys, this hour and 12th hour, will be doing experimental probability with dice. You're going to be doing a lot of you'll be rolling in data charting and stuff like that, and you're going to come up with some experimental probabilities to see if they will match up with their theoretical. We could, okay? But that's kind of what and you're right, Mike, that's exactly what happens is that over a long haul of flipping heads and tails, just flip a coin. If you flip a coin 10 times, you might get 5 heads and 5 tails. You might get 1 heads and no tails. But over the long haul, it should be.
No, you would get
9 tails.
One had 9 tails.
If you get no tails because it landed on fish 9 times, you better go play the lottery. Doing well. So they use experimental probability a lot of times in charts. If they're looking at a probability of an outcome of a data set. I've been told that you guys looked at this in science. I forget what science class it was, but I guess you guys did some probability of some errors.
Oh,
checking.
yeah.
Yeah, you were doing some of that. It's kind of what you were working with. So in essence, you've kind of seen this, just maybe not in the same lingo. So if you're looking at a population chart, and again here, this is nothing so fancy. This is what they're looking at as their experimental data set, just numbers. And if you,
Shoot them together.
I try. Gotta go to Sylvia. Shoot them again. You don't get
I didn't hear you.
Happy Gilmore. Oh, your food. The Happy Gilmore reference of Shooter. Hey Shooter, let's go to Sizzler.
who's food?
Soto.
Jay.
False accusations. I'll get you there.
So if I want to figure out a code of the data set here, you just read it. Your total sample size would then just be the total number of people in the data. Like we've talked about before, this is not a very complex thing. One of the other things we're looking at in this section, though, is good old-fashioned geometric probability.
Is the arrow over there?
Maybe. The geometric probability is when you're looking at favorable area. So you want the favorable area.
Phase. Because Murphy's got a green head.
That's kind of scary. So if I want to find the geometric probability of landing in the bullseye, I'd have to find the area of the bullseye divided by the area of the whole object. And then find the bow and arrow.
Oh no.
Oh.
Pizza. Right in the line of kind.
He's like,
Can I take a shot?
sharpshooters.
He's like,
Can I take a shot?
He's like,
Yeah, you better duck. So, what is the area? What's the area of the bullseye?
I have no idea.
It's a circle!
3
9 pi.
9 pi.
Can you William?
What's the area of the whole thing?
Something.
A lot of pie.
A lot of pi, okay.
I like pie.
Brian and Doc.
That was awful.
Oh, what?
Really? Really?
That was about the worst shot.
You're a good shot. You think you can William
Wait,
John
where did you
Apple
hit it?
with his head?
I hit it up.
He almost did not hit the board.
Oh. That was clone.
Can he one? Can I try?
It's same spot. I'm trying to get a bullseye.
Clown, you hit the clone button.
I'm using a $2 bow and arrow from Walmart here. Come on.
I thought you had like a legit one.
I think they would frown upon the fact of like bringing like a count in. Apparently, I like that spot. Keep hitting that same spot. All right, 2 more times.
Sweating is the next question.
Just tap the bullseye, see what happens.
I got a little closer here. See if it works better. The probability of us getting annoyed by yakking sacks is, 1. Yo.
If I hit the bullseye with at least one of those arrows, and the whole class get 5 points extra credit.
Just hit the bullseye for us.
I almost got the bullseye, but I missed it. That's why I was booing at you.
Jake, what did you say?
I said if I
I
hit
hate
the
this.
bullseye
I
with
have
one
skills.
of those 2 arrows,
Skill.
then I would get 5 points extra.
That was a nice shot.
That was a nice shot.
Solid
Sorry
shot.
if I should hear his idea. I think it's a really good idea.
No, you just
I hit the clone button.
You should try aiming
Yeah, sounds like
Maybe if you shoot where Will is.
Kinda does.
He's been left and
Yeah.
Man, I'm like
You're
way
left
over.
every
Experiment a lot.
Mr. Murphy, this is what you need to do.
Probably when you let
Put
it
the
go.
bow on its side, alright?
Oh, get all gangster with it?
Yeah. Try it.
nails it.
Give a little lock. Oh. That was extremely close.
It was on the right side.
I just want like the principal to come by and just like ask what are you doing?
Yeah, let's try it.
Mr. Murphy, let's set it like let's try.
No, because I want to win. I made it last
You
hour.
already won.
Delete, I
Double or
know.
nothing.
yeah, shoot it.
Wow,
You know, when you let go, you're bringing the string down so it goes upward.
Maybe
Sorry, you're much better with the quiver than I am.
Yeah, shoot it at eye level.
Yeah, shoot it at eye level so you can actually
Shoot it
see.
at eye level, like you're.
Oh, like this?
Yeah. There you go. There you go.
Put your elbow down.
Aim it lower. Aim it lower. No.
Elbow down. There you go.
Perfect.
I opened something, so that's a good sign.
It doesn't go perfectly. You see, you got it.
Alright.
Wait, I'm pretty good at wasting time, aren't I?
Maybe even to do this, Mr.
You're a
Murphy, I'll
man.
go back to my elementary days when I did this.
Oh,
One more.
Oh,
Actually,
you
did
make
actually did
you make
that is weird.
you make Pac-Man sad. Oh my gosh. What did it hit?
I don't know, I did 2 things. Going to win.
This is it. This is it.
Oh.
So close.
Anyway,
Keep going. Keep going. Keep
No,
going.
you can't.
One more. Just 2 more. You can't quit.
There's 2 more arrows there.
Oh, you cheater.
You didn't even get the center.
So wait, is do one of us get to turn it?
not now. So let's make this interesting.
How long does it take you to
How much
program?
time do you have?
Program?
Yeah.
But it's not
Here's
really hard.
what I want to look at.
Program.
That's not even a program. It's just,
Wait, you type in.
It's just link stuff. Let's continue.
there's no program.
Well, you have to type in the link.
No.
Or copy,
All you
whatever.
just don't worry about it. Geometric probability of landing in the shaded region. Perimeter apical. What do you remember?
It's pretty high.
Okay.
That's 16.
Regular polygon. When you're dealing with a regular polygon, the area of a regular polygon is 1/2 the perimeter times the apical. That's, you're thinking about how to find the interior angles. If you're working with a regular polygon and you have to find the area of a regular polygon, you use that 1/2 perimeter apical. Now, if I want to find the area of the shaded region, I want to find the probability of being in the shaded region, I have to find the area of the shaded region divided by the total area. Now, the shaded region is made up of a circle cut out a hexagon. So, what were you going to say?
Is that just the center to the side?
Center to the side is the apical. It is the perpendicular bisector of the side. Now, also, from the center to the angle is also the radius. It also bisects that base angle. When you have regular polygons, that means all of your angles and all of your sides are the same. I heard someone mention the n minus 2 times 180. That gives you the sum. Divided by n, that gives you each angle. In this case, you get 120 degrees for each one of those angles. When you bisect that, you get a 60. So you've got a 30, 60, 90 with an 8 across from here. So across from there is 16, and an apical is 8√3. So I now know that my radius of the circle is 16. So to get the area of the shaded region, I take 16 squared pi. I subtract out from that the 1/2 the perimeter, which is 6 times the 16 times the apical of 8√3, all over the area of the circle.
That looks
Dear.
Now, this is stuff that you guys did last year with some of the generic, what do we call it, polygon areas. I want to just real quickly put in there one to remind you guys of how you set that up. Yes, sir?
Why did you divide it by area of
Because you're finding the favorable area divided by the total area. So the favorable area is found by the circle, subtract the hexagon. The total area is the circle.
Are you trying to find the possibility of?
I want to get the geometric probability of landing in the shaded region.
Oh, okay. So you're just finding
It's very slim.
It is very slim. It was like 0.2 or something like that. Really? I don't know. I don't remember. I think it was like, what, Shay?
So you do 1/2 times all the sides?
Yeah, perimeter. And what I did there is, since I know that there's 6 sides, I just wrote 6 times 16. Then times the apical, which is 8√3.
So 6 times 16.
So this is one of the generic setups that you guys have done way back in the day.
I guess last year.
Yeah, about a year ago from now. So what I want you guys to look at here tonight. Oh, what numbers were they? Oops. Since we've got a little bit of time to go through some of these things, what I want you guys to work on tonight starts on page 719. And I want you guys to do numbers 12 through 34. Page 719. Let's work on those. Now, granted, remember, you guys, I'm probably not going to be collecting this until next Tuesday because you guys would then be ahead of the other 2 classes. So we're just going to hold off on going through a lot. But remember, you've got time to get through it. This is some very, very, very easy material. I have not introduced you guys into any of the permutation combination style. Don't take my post-it notes. Yes, those are mine. Do not worry about, there won't be any permutation or combination style problems yet with the probabilities, but eventually there will be some interlaced within there, okay? When I get started on that, I'll just put it up here for right now. I got a couple other things to pass back to you guys while we're at it.